Okay, so first poster is by France Allard, and it's on the BT Settle model atmospheres. These are, of course, one of a family of different atmospheric models, which we're all using to fit our photometric data points. These models do a great job in explaining the very red colors that we see in the dusty planets and the very red photometry. And it also works out because it can also explain the transmission and the red colors through lower surface gravities. The next one is 512 by David Armstrong. It's circumbinary exoplanets modeling the transit times. So modeling transit timing variations. So what you see here is a similar image to one which Jonathan Fortney showed in his talk. Basically, you don't get away that easily. So the wiggles you see here, he's basically been able to model both the geometric transit timing variation because it's a planet orbiting a binary system, and furthermore, the orbit of the binary itself is precessing. And when you fold those two effects together, you basically get these little fuzzy, fuzzy sinusoidal variation of the transit timing variation. So go along and have a look at that poster. 515 is Joe Barstow solving the inverse problem for exoplanet atmospheres. This is testing the robustness of model atmospheres through model fitting of the transiting planet observations on the ground. Jean-Luc Baudino is looking at a radiative convective equilibrium model for young giant exoplanets and beta pic B. The inputs are the surface gravity and the effective temperature and composition, and it's comparing all these models with 1 to 5 micron photometry. 517 is Daniel Bayliss, who's presenting the results of 3 new planets detected with HAT South. Poster 519 is Kimbot looking at V-star models of hot Jupiter HD 189733b. So this is using new spectral line lists to look at this very hot exoplanet, which is 5,000 Kelvin. And so it's highly irradiated, and you have to do new modeling for the temperature, carbon-oxygen ratio, and the water that you see there. Okay, so 520 is oh, no, that's not 520 at all. Yes, 520 is Duncan Christie looking at hydrogen alpha in transiting exoplanet atmospheres, and essentially this is looking at, instead of Lyman alpha absorption that we've seen before, it's looking at hydrogen alpha absorption, the next transition up, and it's by modeling the creation and destruction pathways of the hydrogen beta line, hydrogen alpha line. Duncan basically models it and is able to reproduce the absorption profile that you see in the transiting spectra. 520 I think, yes, is Thomas Beattie. Oh, no. And unfortunately, I've got my notes muddled up, so I'll just leave this here for a couple of seconds of deep and meaningful thought. Sorry. And here is 524, Eric Gaidos, with candidate planets in the habitable zones of Kepler stars. So this is taking the stellar parameters of the 2,000 host stars, estimate them with synthetic photometry and a Bayesian prior of the stellar parameters, and basically finding how wide your habitable zone is. The uncertainties in the habitable zone are dominated by the lack of parallax to the Kepler stars, but they use a spectroscopy of known nearby dwarfs to reassess the distances to Kepler. I also think this is the best candidate for most appropriate use of a word balloon in the poster slide. The hosts project. So this is the homogeneous study of transiting systems by Elon Gomez Maceo Chu. This is using high-resolution shell spectra to tighten up the stellar and planet properties of over 150 systems. You can see the improvement with WASP-13b here. So this is the old measurement, and this is using the new and improved determined parameters. So this looks to be a very exciting method for determining tighter parameters on the star. So Derek Homaya is one-dimensional atmospheres and RHD simulations. So using dynamical simulations of the vertical transport in brown dwarf atmospheres, he can explain the L to T transition through the formation and destruction of clouds. Extending this work down towards exoplanet masses is the subject of the poster, and basically getting down to the low gravity objects and the associated carbon chemistry that we've heard a lot about today. John T. Horner is poster 531, and it's talking about the dynamical constraints of multi-planet systems, essentially taking the published solutions of multi-planet systems and finding out that some of them basically aren't consistent. As the very famous exoplanet astronomer Friedrich Nietzsche once said, once you stare at the data, sometimes the data stares back at you. And I think this is a cautionary tale for all of us in this field, I think. So we're halfway there. So Zhu Huang is using Kepler as a calibrator, using the Kepler smaller transiting planets that have been observed with HAT to improve the HAT pipeline and improve the detection efficiency in the larger area survey of the HAT fields. Very exciting to see what planets will be pulled out. Marshall Johnson, 533, is Doppler tomographic observations Kepler 13b. This is basically a very neat technique where basically you use an analog of the Roster-McLaughlin effect, and it's useful on fast rotating stars where RV conformations aren't possible. Daniel Jontoff-Hutter filling in the mass radius diagram for super-Earths and sub-Neptunes. Dynamical modeling of transit timing variations in multi-planet systems to find the orbital parameters of the longer period transiting planets, leading to tightening parameters on the star and planetary radii. Quinn Konopaki showing carbon and oxygen in the spectrum of HR8799c, this beautiful spectrum which we've seen referred to several times, and basically seeing the methane and carbon monoxide, especially the carbon monoxide absorption feature here, constrained to the C/O ratio. Cezary Migasiewski, a linear distribution of objects in compact planetary systems. This is basically showing that the dynamical orbital evolution of planets leads to compact configurations through mean motion resonances. Matthias Muller has transmission spectroscopy of an inflated planet with the OSIRIS at the Grand Tecan telescope, and this is ground-based transit spectroscopy with very exquisite looking data from the telescope to constrain the atmosphere around the sodium and potassium absorption lines in the visible. Abhijit Rajan, with poster 5.40, searching for photometric variability across Y, L, and T, and that's showing basically roughly a quarter to a third of surveyed L and T stars are variable above 10 millimagnitudes. And here we see 2M2139, which is showing a variability of 0.1 magnitude. Evgenia Shkolnik is hazmat, the habitable zone and M dwarf across time. This is a very interesting idea. So basically looking at the far UV and near UV flux from M dwarfs using galaxy observations of M dwarfs nearby in a galaxy to basically build a time history of how much UV radiation an M dwarf star puts out. And basically if it's too strong, does it strip away the atmosphere of any planet in a nearby habitable zone? There's a 545 is Joanna Teska is the role of oxygen abundances in exoplanet host star C/O ratios. Essentially, it's all well and good to talk about your C/O ratio, but if your NLTE models introduce very big biases, then whenever you see a quoted C/O ratio, you must treat it very suspiciously and wonder exactly what the systematic errors are involved in that. There was also a purple version, but I just went for the black and white version instead. Where are we now? Quantifying WASP selection effect. So Simon Walker 5.48, taking out the biases from ground-based WASP surveys to discover a pile-up of hot Jupiters at 3 to 5 days, and this constrains models of hot Jupiter migration. So basically, it's very nice seeing this strong pile-up feature up at 4 days, which you don't see in the Kepler data because there basically aren't enough detections of hot Jupiter planets in it. 550 is Sloan Viktorovitz, a stormy exoplanet seen in polarimetry, and this is showing something which I haven't seen an awful lot of, which is basically polarization measurements. The light scattered off these exoplanet atmospheres also encodes polarization measurements, which we can look at to see what the aerosol and particulates are doing. and basically he is discovering evidence that these atmospheres could be quite turbulent, and the polarization signal is not quite what you'd expect. Rob Wittenweyer is testing single eccentric planetary systems for the multiple companions. So by basically replacing a single eccentric orbit fits with 2 planets on more circular orbits seems to give a better solution. And of course, this has the best prize for using the internet meme generator. So with that, we have 30 minutes for, I believe, 30 minutes, or is it? Sorry, I've just